Imagine you're in a genetics class. It's a supplemental session, optional, meant to help reinforce concepts from the main lectures. The topic today is blood type inheritance. Simple stuff, really. Punnett squares. A plus B equals AB. O is recessive. Basic Mendelian genetics that's been understood for over a century. The instructor asks if anyone knows their parents' blood types to use as an example. One student raises his hand, eager to participate. And in the next 5 minutes, his entire understanding of his family is about to shatter. Because sometimes science doesn't lie, and when it doesn't lie, it reveals truths that maybe should have stayed hidden. This is the story of how a simple genetics lesson accidentally exposed a family secret that had been buried for nearly 2 decades. Let's start with our narrator. He's an 18-year-old university student, which means he's probably a freshman or sophomore. Despite his young age, he has a part-time job on campus as a supplemental instructor for genetics. Now, for those unfamiliar with how universities work, a supplemental instructor isn't the main professor. They're usually upper-level students or recent graduates who help reinforce concepts taught in lectures. Think of it like this. The professor teaches the course. They give lectures, assign readings, create exams. The supplemental instructor runs optional side sessions where students can get extra help. It's like a structured study group led by someone who recently took the same course and did well in it. It's actually a pretty common system at universities. It helps struggling students get additional support, and it gives advanced students teaching experience and a paycheck. Our narrator describes his job pretty simply. My job basically revolves around reinforcing concepts already taught by the professor as an optional side course. Not glamorous, not high pressure. Just going over the material again, making sure students understand it, answering questions. Genetics can be tricky, especially when you get into inheritance patterns, DNA replication, gene expression. Having someone closer to your age explain it in simpler terms often helps. Earlier in the semester, the topic was parental blood typing. This is a classic genetics lesson. It's concrete, it's applicable to real life, and it's fairly straightforward to understand once you grasp the basics. Human blood types are determined by the ABO gene, which has 3 alleles, A, B, and O. You inherit 1 allele from each parent, giving you 2 total. Here's how it works. If you have 2 A alleles, you're type A. 2 B alleles, you're type B. 1 A and 1 B, you're type AB. 2 O alleles, you're type O. If you have 1 A and 1 O, you're type A because A is dominant. Same with B and O, you'd be type B. It's simple, dominant recessive inheritance, the kind of thing Gregor Mendel figured out with pea plants in the 1860s. Our instructor was going over this concept using Punnett squares. These are those little grids you probably remember from high school biology. You put one parent's alleles on the top, one parent's alleles on the side, and fill in the squares to see what combinations the offspring might have. It's visual, it's straightforward, and it makes genetic probability easy to understand. To make the lesson more engaging, the instructor asked if anyone in the class knew their parents' blood types. This is a smart teaching move, actually. Instead of using hypothetical examples, you use real data from the students themselves. It makes the lesson personal. It helps students connect abstract genetic concepts to their own lives. One student raised his hand. He volunteered his information confidently. According to the student, his father was type AB, his mother was type A, and he himself was type O. 3 pieces of information. Simple blood types. The kind of thing you might know from medical records, from donating blood, from family conversations. The instructor, let's imagine them writing this on the board. Father, AB. Mother, A. Son, O. Time to fill in the Punnett square and show how inheritance works. Except there was a problem. A massive, unavoidable, scientifically impossible problem. Here's the thing about blood type inheritance. It follows very strict rules. These aren't suggestions. They're not probabilities that might sometimes work out differently. They're absolute biological facts that have been verified millions of times through genetic testing, paternity tests, and basic science. If a father is type AB, he has one A allele and one B allele. That's what AB means. He cannot have an O allele. It's impossible. He will pass either an A or a B to his children. Every single child he has will receive either his A or his B. There's no other option. If a mother is type A, she has either two A alleles or one A and one O. We'd write this as AA or AO. She'll pass either an A or, if she has the O allele, possibly an O to her children. Now, for a child to be type O, they need two O alleles, one from each parent. O is recessive, meaning you need two copies for it to show up. If you have one O and one A, you're type A. One O and one B, you're type B. To be type O, it has to be O and O. So let's do the math here. Father is AB. He can only give A or B. Mother is A, so she's either AA or AO. Best case scenario for making this work, mother is AO and can give an O. But even then, the father can only give A or B. The possible combinations are A from mum plus A from dad equals AA, type A. A from mum plus B from dad equals AB. O from mum plus A from dad equals AO, type A. O from mum plus B from dad equals BO, type B. Notice something missing? There's no way to get type O. It's impossible. Biologically, genetically, scientifically impossible. The instructor realized this immediately. They're teaching genetics. They know how inheritance works. They can see that the numbers don't add up. Father AB, mother A, child O? That doesn't compute. That violates basic Mendelian genetics. But here's where it gets uncomfortable. This isn't happening in the instructor's head. This isn't a quiet realization they can keep to themselves. They're in the middle of a class, with multiple students watching. They've already started the activity. They've already put the students' family information on the board as an example. The instructor writes in their Reddit post, "I went through with the activity for some reason." Why would they do this? Why not just say, "Actually, let's use a different example," and move on? Probably because they were caught off guard. Probably because backing out would have been even more suspicious. Probably because they were 18 years old, relatively new to teaching, and panicking about what to do. So they kept going. They filled in the Punnett square. They showed the possible combinations. And then they had to explain why the student's blood type didn't match what the genetics predicted. The instructor's exact words ended up having to explain to him that the only way this can happen is if his mother is AO and his father was type O, AO, or BO. In other words, the man this student calls father is not his biological father. The genetics don't lie. For this student to be type O with a mother who's type A, his biological father must have an O allele to give him. Type AB fathers don't have O alleles. Try to imagine this moment. You're sitting in a supplemental genetics class. It's optional. You're just there to get some extra help understanding inheritance patterns. The instructor asks for volunteers to use real family examples. You think, sure, why not? You raise your hand. You confidently state your parents' blood types and your own. And then the instructor, this 18-year-old student just like you, has to explain in front of the entire class that the genetics don't work. That based on the laws of biological inheritance, the man you call your father cannot possibly be your biological father. That either you were adopted and never told, or your mother had an affair, and the man who raised you isn't genetically related to you. The instructor writes, he now didn't know if he was adopted or if his mum cheated on his dad. That's the only explanation. Those are the only two possibilities. Either this student's entire origin story is a lie, his parents adopted him and never mentioned it, or his mother was unfaithful and has been keeping that secret for almost 2 decades. And he found this out in a classroom, surrounded by peers, from an 18-year-old supplemental instructor who was just trying to teach a basic genetics lesson. Not from a private family conversation, not from a DNA test he chose to take, from a Punnett square, from basic high school level biology. The other students in that room must have been stunned. Some probably realized what was happening before the explanation finished. Anyone who paid attention in biology would know that AB plus A can't make O. They watched in real time as their classmates' world potentially fell apart. After the session ended, the instructor did what any responsible person would do in this situation. They went to talk to the actual professor, the one in charge of the course. The instructor needed confirmation that they hadn't made a mistake, that their understanding of genetics was correct, that this wasn't some rare exception they'd forgotten about.
The instructor writes, "After the session, I walked over to the genetics professor's office and confirmed with her that this was impossible, and she said she'd be mortified to try to tell him." Even the professor, someone with far more experience and education, admits she would be mortified to be in this situation. And that's because this is genuinely one of the most uncomfortable things that can happen in a science class. Science is supposed to be neutral, objective. You're teaching facts about alleles and inheritance and Punnett squares. You're not supposed to accidentally expose family secrets. You're not supposed to destroy someone's understanding of their parentage during an optional study session. But genetics doesn't care about feelings. It doesn't care about family harmony. It doesn't care that this student probably had a great relationship with his father. It just is. The numbers work, or they don't. The blood types are compatible, or they aren't. And in this case, they absolutely weren't. This isn't even the first time something like this has happened. There are famous stories of genetics professors who refuse to use blood type examples anymore, specifically because this situation comes up semi-regularly. Students volunteer their family's information, not realizing it's genetically impossible, and suddenly there's a massive problem in the middle of class. Some instructors have policies now. They don't use real family data, they only use hypothetical examples. They specifically avoid topics that might accidentally reveal adoption, affairs, or other family secrets. Because once you say it out loud in front of a class, you can't take it back. The post concludes with a simple TLDR. I teach genetics, and a student of mine found out that his mother cheated on his father. Note the quotes around teach. The instructor is acknowledging they're not a real professor. They're just a supplemental instructor. An 18-year-old student themselves, trying to help other students understand genetics, and they accidentally dropped a nuclear bomb into someone's family. What happened to that student after class? The post doesn't say. Did he confront his parents? Did he demand an explanation? Did he get a DNA test to confirm? Did he discover he was adopted? Or did he learn that his mother had an affair nearly 2 decades ago and has been lying about his paternity his entire life? We don't know. And honestly, that might be worse than knowing. The uncertainty. The not knowing which terrible option is the truth. Either way, his family will never be the same. This story raises some serious ethical questions. Should the instructor have said something different? Should they have lied about the genetics? Should they have stopped the activity the moment they realized the blood types didn't match? Some people might say yes, that protecting this student's peace of mind was more important than genetic accuracy, that a white lie in a supplemental genetics session isn't the end of the world, that there was no reason to destroy this family over a Punnett square. But others would argue the instructor did the right thing. Science is science. You can't lie about basic biological facts. If you're teaching genetics, you have to teach it accurately. And if that accuracy reveals uncomfortable truths, well, maybe those truths needed to come out eventually anyway. There's also the question of whether the student had a right to know. If you're not biologically related to the man you call your father, shouldn't you know that? Don't you have a right to understand your own genetic history? What if there are medical implications? What if there are hereditary conditions from your actual biological father that you need to be aware of? Adopted children often search for their biological parents later in life, specifically to understand their genetic health risks. Heart disease, cancer, diabetes, countless conditions have genetic components. If you don't know your real biological parentage, you can't accurately assess your risk for these conditions. So, while the revelation was devastating, it might ultimately be important information. Not the way anyone would want to find out. Not in a classroom, not from an 18-year-old instructor, not in front of peers, but important nonetheless. Let's talk about the science itself for a moment, because this isn't speculation. This isn't, well, maybe the genetics are weird. The ABO blood type system is one of the most studied and well-understood aspects of human genetics. We've been testing blood types for over a century. We've done millions of paternity tests. The rules are ironclad. There are rare mutations. There are extremely rare genetic conditions that can affect blood type expression. But we're talking about 1 in millions. And even those wouldn't typically result in this specific combination. The most likely explanations remain: adoption or infidelity. And given that the student apparently didn't know he was adopted, if that's the case, it was kept secret for a reason. Which means either way, there's a massive family secret that just got exposed. What's particularly tragic about this story is how easily it could have been avoided. Don't use real student data for sensitive examples. Don't ask students to volunteer personal genetic information. Use hypothetical families.
Make up blood types that you know work. It's such a simple precaution. But hindsight is 2020. The instructor probably thought using real examples would be more engaging, more relatable, more helpful for learning. They didn't anticipate that a student would volunteer information that was genetically impossible. Most families don't have these kinds of secrets. Most students who know their parents' blood types are actually biologically related to those parents. The instructor made a split-second decision to continue with the example rather than backing out awkwardly. In that moment, they probably thought finishing the activity and moving on quickly would be less suspicious than suddenly changing course. They didn't realize they were about to explain to a student that his father might not be his father. This story went viral when it was shared on Reddit's Tfue subreddit. Thousands of people commented. Some shared similar stories. Some genetics professors admitted they'd had close calls with these kinds of situations. Some adoptees shared how they'd discovered their adoption through genetics classes or DNA tests. One interesting pattern in the comments: a lot of people defending the instructor, saying they did nothing wrong, that they were teaching science accurately, that lying about genetics would have been worse than telling an uncomfortable truth. But there were also people who felt the instructor should have found a way to handle it differently. Maybe pull the student aside after class. Maybe say, let's use a different example and discuss it privately. Maybe give the student a heads up that there might be something unusual about his family's genetics and he should talk to his parents about it. The truth is, there's probably no perfect way to handle this situation. Once you're in the middle of it, in front of a class, you have seconds to decide what to do. Any choice is going to be uncomfortable. Any choice risks causing harm. What this story really illustrates is the power of genetic information. We're living in an age where DNA tests are everywhere. 23andMe, Ancestry.com, paternity tests you can buy at pharmacies. Genetic information that used to be hidden is now easily accessible, and that's revealing secrets left and right. There are countless stories of people discovering through DNA tests that they're not related to their supposed fathers, that they have half-siblings they never knew about, that their grandparents weren't who they thought. Whole family trees are being rewritten. Some people argue this is good, that truth is important, that people deserve to know their real biological heritage, that secrets cause more harm than revelation, that medical information tied to genetics is crucial for healthcare. Others argue it's destructive, that some secrets exist for good reasons, that a man who raised you is your father regardless of genetics,
that destroying families over DNA is cruel, that ignorance can sometimes be bliss. The student in this story is caught in the middle of that debate. Through no choice of his own, through a random genetics lesson, his family's secret was exposed. What he chooses to do with that information is up to him. Does he confront his parents? Does he demand to know the truth? Does he get a paternity test to confirm what the genetics already told him? Or does he choose to ignore it? To pretend the lesson never happened? To keep living with the same family he's always known, regardless of biological reality? There's no right answer. Some people would absolutely need to know the truth, would feel betrayed by the secret keeping, would want answers about their biological father, their real genetic heritage, why they were lied to. Others might prefer not to know,
Might feel that the man who raised them is their real father in every way that matters. Might not want to blow up their family over chromosomes and alleles. Might choose emotional truth over biological truth. The instructor, meanwhile, has to live with what happened. They were just trying to do their job, trying to help students learn genetics, and they accidentally destroyed someone's understanding of their family. That's going to weigh on you. Even if you did everything technically correctly, even if the science was accurate, even if there was no malicious intent. This is why teaching is hard, especially teaching science that intersects with personal identity. Genetics, evolution, anthropology, these fields touch on questions about who we are, where we come from, how we're related to each other. Teaching them requires not just scientific knowledge, but also sensitivity, awareness, and sometimes ethical judgment. The story ends without resolution. We don't know how the student processed this information. We don't know if he talked to his parents. We don't know if he was adopted or if his mother had an affair. We don't know if his family stayed together or fell apart. We don't know if he wishes he'd never raised his hand that day. What we do know is that a simple genetics lesson became a life-changing moment. That basic science, taught accurately, revealed a truth that had been hidden for nearly 2 decades. That sometimes education doesn't just teach us about the world around us, it teaches us about ourselves. And sometimes those lessons are devastating. For anyone reading this story and thinking about their own genetics, here's something to consider. If you're curious about your biological parentage, there are ways to find out privately. DNA tests are cheap and easy. You can learn your genetic heritage without doing it in front of a classroom. You can have conversations with your parents in private.
You can process information on your own terms. But once you know, you can't unknow. Once the genetic truth is revealed, you have to deal with it. Whether that truth brings peace or devastation depends on what it reveals and how you handle it. The instructor ended their Reddit post with a simple statement. TLDR. I teach genetics, and a student of mine found out that his mother cheated on his father. That's the summary. That's the whole story in one sentence. But behind that sentence is a student whose life changed forever during an optional study session on a random Tuesday or Thursday afternoon. Science doesn't care about our feelings. It doesn't care about our family structures or our emotional attachments or our carefully maintained secrets. It just is. DNA is DNA. Blood types follow rules. Inheritance patterns don't lie. And sometimes, when we teach those scientific truths, we accidentally reveal human truths. Truths about affairs and adoptions, and families built on lies, or love, or both. Truths that maybe should have stayed hidden, or maybe needed to come out. Truths that change everything. The instructor was 18 years old, still practically a kid themselves, trying to help other students learn about genetics. And they became the unwitting messenger of life-altering information. That's a heavy burden. That's the kind of thing you remember forever. The day you accidentally told someone their father might not be their father because the Punnett square didn't lie. This story serves as a cautionary tale for educators. Be careful with real personal data in sensitive subjects.
Think through potential implications before asking students to volunteer family information. Have plans for how to handle uncomfortable discoveries. And maybe, just maybe, stick to hypothetical examples when teaching genetics. And for students, maybe don't volunteer your family's genetic information in class.
Because you never know what the science might reveal. And once it's revealed, in front of everyone, you can't put it back. The truth is out there, and sometimes the truth hurts. In the intersection of science and human life, sometimes the most objective truths reveal the most subjective pain. An 18-year-old supplemental instructor learnt that teaching genetics means more than just explaining Punnett squares. It means navigating the ethical minefield of information that can change lives. And a student learnt that sometimes the most important lessons happen when you least expect them.